In this video, we're going to show you how to use the graph screen in CamPro Plus. This is the lobe list area. These are the lobe measurements that we're working with. And this area is the curve list. Each curve is a different type of data that can be plotted for each of the lobes. This big area of the screen is for the graph. The lobe list that we looked at first and then the curve list control what appears in this area. Both of those lists have a tag column. This is the curve list tag column. An X in this column means that the curve is turned on, and the one in the lobe list would also have to have something turned on to have something show up. You can tag in either list by double-clicking on the curve list's name of the curve or the name of the lobe in the lobe list. Also, if there's a cyan background behind the list, then you can just use the space bar to toggle that tag. To adjust the width of the columns in the list, you place the mouse on the border between the columns in the title row and then click and drag. Here's an illustration. On the border, double-headed arrow appears, click and drag. Double-headed arrow, click and drag. Double-headed arrow, yeah, there you go, click and drag. And you see you can adjust the columns. You could also make them smaller, adjust them whatever you need them to be, however you need to fit things on the screen. The space that's used by the graphs and the list and the notes area, which is the little area between the two lists, can also be adjusted by going to the borders, and when you get the double-headed arrow, you click and drag. And then we can put things back. That area there in the middle is for notes. It shows the notes of whatever cam in the lobe list has the highlight. Now here in this graph, you see an exhaust lobe on the left, normal position for it, intake lobe on the right, and these are just C-lift curves, in other words, the follower motion. The area in the middle, that is your overlap, where the green and the blue cross each other, or green and the red cross each other. We only have the C-lift curve showing up because it's the only one that's tagged. Now let's turn on the velocity curve by tagging the CVEL curve. That makes a lot of lines, and you can get rid of some of them by turning off one of the lobes. We'll turn off the exhaust so we only see the intake. If we want to expand an area of the graph or zoom in on it, we can do that. We'll place the mouse cursor at the upper left corner of the area that we want to zoom in on. In this case, we'll look in at the overlap. Click and drag to lower right, and then when we release, that area becomes full screen. We could do the same thing to zoom in even further. Up here in the toolbar, you have this icon next to the color icon. You click on that, that's your unzoom, and we're back to full screen. Now, a little gotcha to be aware of is if you're moving the mouse over the graph and you accidentally bump the button as you're moving, you can zoom into an area of the screen where there nothing is. And you don't expect that, so you go, what happened? My curves disappeared. No, they didn't disappear. Just click the unzoom button, and there you go, they're back. Now, another feature, as long as we're talking about zooming in full screen, if we go up to the window menu, we have hide show list with F9 being the hotkey. Click on that, the lists go away. We've got a nice big graph to work with. Need the list back, just hit the F9 key. Each of the lists has a column titled value. The lobe list has one, the curve list has one. On the graph screen, we have these vertical lines. The value line is the green one. I can grab the triangle at the top of the value line, click the mouse, and drag it to a new position. As I do that, you'll notice that the numeric value that indicates its position right here will change. If I get it to move, there we go. I could also put an exact value in the entry blank there, and it will move the line to that. Now, the line position here interacts with the value columns in the list. Now, at the moment, the value columns in the list are values at a 75 degrees, minus 75, before top dead center. And at the moment, all these values in the curve list are values for intake 2, cam 1, because that's where the highlight is over here in the lobe list. And the values that are in the lobe list value column are all C-lift values, because that's where the highlight is in the curve list over here. Now, if I move the highlight, for instance, in the curve list, move it down to V-lift, you'll see that the values in the other list change, and likewise there. So they all interact. Then we have two blue lines, a left line right there and a right line. Now, those two lines form the boundaries for a region, and they interact in the same way as the value line does, but they interact with the area and average columns in each list. The average column will give us the average value between the two lines, and the area column will give us the area under the curve between the two lines. You'll also notice we have a little red triangle here. Now, if I right-click that, it will turn on our reference line. The reference line works with the green value line, and when it's on, instead of getting the actual values at the position of the value line, you get the difference between the values there and the values at the reference line. Now, most of the time, I leave that turned off, but once in a while it comes in really handy. And again, it's a right click on its triangle to turn it on and off. That leaves one entry blank here labeled step that we haven't covered yet. Now, you notice these entry blanks all have a little up arrow, down arrow next to them, and you can use that by clicking on it to move the lines. Well, how much do they move each time? Well, that's what this step value is. At the moment it's set for 15 degrees, so if I click it, it will move 15 degrees. I could reduce that, and then they don't move quite as far, only 5 degrees each time. That leaves 5 columns that we haven't covered yet. Those are the runout, lash, rocker, center line, and smooth columns. And you notice that the column titles for those 5 columns over here in the lobe list are all caps, and where all the other column titles are mixed case. That's just a subtle visual clue that you can actually edit the values in those columns, where the other columns are just giving you fixed information like the name of the curve or the lobe, or giving you feedback from the line positions. And so we'll go over here, turn on the V-lift curve, and you can see our valve lift is taller than our cam lift, and that's because at the moment we have a rocker ratio greater than 1. In fact, this rocker ratio over here is 2.0, kind of a little aggressive. So let's change that to something a little more realistic, normal. Let's make it 1.6. And I tab off of that entry blank. It takes the value, and the lift curve reduces down to a 1.6 rocker ratio. You also have the lash column here. Now, the lash interacts with the rocker ratio to produce the lift curve. At the moment, it's set for 20 thousandths. Just to show you what it does, I'm going to put in something crazy like 120 thousandths. And you see, the lift curve has to chew up 120 thousandths of lash before it can even start to move. So let's put that back to 20 thousandths. Okay. Center line. Center line column over here. At the moment it's set to 100. And since this is an intake and it's a positive value, that means 100 degrees after top dead center, which is in the middle of our screen. And I can change that. Let's make it a 105. And we do that, and everything shifts a little bit to the right. So now our center line is at 105. Another way to change center line is to use the advanced retard command up here on the edit menu. Now on this one, you have a choice of what you want it to apply to. It could be just this lobe, just this cylinder, just every lobe on this camshaft, or if you have a multiple camshaft engine, the entire engine. We'll do it to the cylinder. We have the mating lobe for this one loaded, the exhaust, the E2 lobe there on cam, the second one in our list. And we'll change the advance to 10 degrees. Now, advance is going to be earlier in time, and time starts at the left edge of our graph, so that will move my curves to the left. And so before we do this, we see that our intake center line is at 105 after, and our exhaust center line is at, indicated by the negative, is at 110 before. So I apply that, and now our 105 became 95, and our 110 became 120. That leaves the smoothing column. Now to show how that works, we're going to turn off V-lift, turn on the acceleration and the jerk. And that brings up those curves. Now I'm going to set the smoothing to 0, which effectively turns it off. And you say, wow, where did all that stuff come from? Well, that's what you get if you have the raw data with no smoothing applied. So why do we need smoothing? Well, the linear motion sensor that CamPro Plus uses is a very fine device, and it can measure 1 micron of movement. That's a thousandth of a millimeter, or about 4/10 of a 10,000th of an inch. So it's a pretty small amount. You can measure 1 micron, measure 2 microns, not do anything in between there, like 1 1/4 or 1 1/3 or 1 1/2. So you end up with a little bit of stair-steppiness in the data, and that, as the math propagates that stair-steppiness through, you get this hash showing up in the velocity, acceleration, and jerk curves, and it gets worse as you go from velocity to acceleration and from acceleration to jerk. It's just the way the math works. So what we do to eliminate that artifact of the measuring process is we use the software to apply a little bit of smoothing. I'll put in 5. And you see there's still some artificial hash there. Let's make it 10. And still a minor amount, we'll go to 15. Now you can go overboard on this, and I don't recommend it. Let's put in something crazy like 200. Say, oh wow, nice smooth, yeah, but not real. Unless this was mathematically designed camshaft data, design data, not a measurement from a real camshaft, you're not going to see stuff that smooth. Normally you'd be around 5 to 15 for your smoothing. Now, there's an entry elsewhere in the software where you tell it how much smoothing to use for newly measured lobes. Now for the run-out column, we'll turn off the jerk, the acceleration, and we'll turn on the run-out. Now, run-out is base circle run-out. And the run-out curve, what it is the lift curve highly amplified, so that you can see minor changes in the base circle. And you can see here that it goes, whew, that's where the ramps are just starting, and over here the ramps at the end. And then what we're seeing here, this is a pretty good cam. It has just a very little bit of run out. It's down in the 10,000ths of an inch total run out. Let's turn off the lift curve, and we'll turn on a few of these others to see what we have. Now this exhaust lobe, it's got a little bit more stuff happening in its run out. That intake was very good. It's not common to have one be that small. The exhaust lobe would be more common representation. And we'll check these holding cams we have up here. Oh, okay, that's not unusual. And there likewise. Now, the software, when you measure the lobe, it analyzes the data and comes up with a runout number. It's an editable entry here, so if you look at it and go, the software screwed it up, it got it wrong, we change this. I'm just going to fix it, overrule the software, and tell it what the runout is. You have that prerogative to do that. What the program does with that is it takes whatever number you put in here and chops that much off the bottom of all the data, with the lowest point on the base circle being the absolute 0 point, and then works with the rest of it from there. In most cases, that makes a very minor difference, perhaps in some of your timing points, because they depend on height from 0, from the base circle, and you've moved where the base circle is slightly. I look at it as what you're doing is you're eliminating the effect of the runout. Other people may look at it and go, no, you're screwing with the data. Fine. Change the runout to what you think it ought to be and work with it from there. Unless you've got a cam with a lot of runout in it, it's not going to make much difference anyway. But it's there. You can see it. You could also look at it and go, wow, a lot of runout. There's something wrong here. The cam grinder goofed, or the camshaft's been abused and it's bent. But at least you get to see what it is. That's runout. Thanks for watching this video. Search for Audie Technology to find some of our other instructional videos.